So, namespace routing. So the naming of this actually confused me when Richard first kind of coined the term to me. So, do you want to just kind of explain what you mean by
Sure.
namespace routing?
So namespace routing, or routing, as we say here in the United States, namespace routing is the concept of it's a parallel to IP network routing, right? Where we define a route. This route says the 10.0.0.0/8 network goes over this interface. That's like an IP route. A namespace route would be star.example.net routes over the tunnel, or mail.example.net routes over the tunnel. So one of the things for anybody on the call who's familiar with the direct access, this was really, really simple because direct access used the name resolution policy table, but it also used IPv6. And so with DNS 6.4 and NAT 6.4, when you made a request that was in the NRPT, it would send it to the direct access server and you would get an IPv6 address back, a synthesized IPv6 address back. So you could say, some public website, www.example.net, I actually want to resolve over the tunnel. It would get back an IPv6 address that maps to the public address, and then I would route that over the tunnel because that IPv6 address was routable only over the direct access tunnel. So in namespace routing, also I refer to it sometimes as selective tunneling. So that's maybe a more accurate term. But principally speaking, what we're doing is we're taking some external properties, public websites, and routing them over the tunnel for whatever purpose we need. The most common scenario would be I have a SaaS application in the cloud, but it is ACL'd to my on-premises network. So you have to be in my building within my four walls, going out of my internet egress at my organization's physical address to be able to access the application. So if I access it from the internet or from a non-managed machine or what else, then it doesn't work. So in that case, if I have users who are field-based and they're connected via always on VPN, I need them to take that particular namespace, route it over the tunnel so that they can get to the internet and appear to be coming from on-premises. But I don't want to do forced tunneling. So if you did forced tunneling, it'd be really easy. Everything comes over the tunnel. You don't have anything to worry about. But in the case of selective routing or selective tunneling or namespace routing, what we want to do is say, hey, we want to do split tunneling. So all of my regular internet traffic just go to the internet. I don't want to bring that over the tunnel. But this particular property I need to. So www.example.net or app.example.net. So the challenge with always on VPN is that I can very easily tailor where my DNS queries are sent. In other words, I could send the name resolution request for that namespace over the tunnel. The challenge is that always on VPN uses IPv4. So what it's going to do is just going to give me the public IP address back, right? And then it's going to go directly to the internet. So I have routed the name resolution request, but I can't route that over the internet. Now, the quick and dirty way to fix this is to add those public IP addresses to the routing table. So if it's a simple IP address or two, awesome. I can actually add those to my routing table and fix that. The problem comes from when you have websites that are using dynamically changing IP addresses, or you have websites that have many, many addresses. So those become really problematic. So what you could do is do a resolve DNS name or NSLOOKUP or dig, whatever you want, get all the IP addresses, put it in the routing table, and guess what? When it changes, you're gonna have to go back and touch all your clients again. So that's really problematic. Always on VPN does not natively have a way to route namespace. I can't do that like we did very easily in direct access. But Leo came up with a very clever way to do this. And Leo, if you would explain your solution to this. Well, actually, before I proceed, the other way I solve this is actually to build a proxy server infrastructure. So I've actually helped customers stand up proxies on premises. Typically, you just use Squid running on Linux, although it does run on Windows. You can port it. You can use one of the Windows ports. And then what we have to do is we have to host a proxy auto configuration file or a pack file. And then in that pack file, we say if the namespace matches this, route to the proxy, and the proxy is reachable over the tunnel. So obviously there are ways to approach this, but again, Leo came up with a very clever way to do this and make it kind of functional and manageable. So if you could enlighten us.
Yeah, sure.
Leo, that'd be great.
So we'll use the example of bbc.co.uk because that's a relatively good one in terms that it's got multiple addresses that it will resolve to. And ultimately, as a as Power on platforms, we have zero control over what the BBC do from a public IP addressing perspective, and they do not guarantee that these will be the only IP addresses ever used. Which we could, just take this list, statically assign it in our route table, and hope for the best. But ultimately, I can pretty much guarantee you that these will switch out, and therefore you'll start getting weird inconsistencies when trying to talk to bbc.co.uk. You might get some support cases of like, oh yeah, this site's broken or slow or any number of other things. So it's much better to do this stuff dynamically. So what we've got in DPC now is we've got this option of allowed routes from DNS, and we can go in there, edit that, and we can actually add in the site, and you can just add in a comment as well. So what that's actually going to do is it's going to that gets sent down to the client, and as when the DPC agent attempts to build up its route table from the other configurations, it will then take the DNS route list, it will do an NS lookup on it at client runtime, and then generate the new profile or add that into the route list dynamically. So that's got a couple of advantages from a kind of both from a user experience and from a administrative perspective. The first one being is that DPC generates its profiles typically on an hourly basis, although that is a configurable setting. So should the BBC change their IP address list in an hour's time, depending on how much they change that list, you could get a little bit of a few issues during that time. But ultimately, within an hour, all of your DPC clients are going to pick up the new set of DNS. They're going to rebuild their IP address list. Notice that the currently installed profile is different from the new profile because the BBC IPs have changed, and therefore will change the connect or the deployed tunnel to the end users without the administrators even needing to be aware that the BBC have done that. This can also be a useful. The classic case is those AWS websites where the whole of the AWS namespace is just, or Azure or any of the cloud providers, is just ridiculously huge, and customers have even the people using those systems, unless they go and explicitly pay for static IP addresses, they have very little control over where their IP addresses are going to be. So that can cause some issues at some times. Now, there are limitations to this approach. The key one being that fundamentally behind the scenes, this is just an NS lookup. Therefore, the actual address in the route list needs to be resolvable. So that classic case of, I want to put all of my Windows updates through it. And now if you go look at the update list for Windows Update, it'll be star.windowsupdate.com. And unfortunately, we just can't handle that, because the only way to handle that would be to start doing a kind of brute force attack of like a.windowsupdate.com, b.etc.
Yeah.
And that's just not feasible or functional. So it does have to be a resolvable address. And the other thing is that the clients do need to be able to resolve that IP address or those or that traffic. If it can't resolve it at the point of the generation, there is a fallback mechanism where it caches the last known good version. And it will continue to use that until it can re-resolve it, and it does put a warning in the event logs. But fundamentally, if the client, especially on the first launch, can't access or can't resolve that IP address, then it's or that address DNS2 IP address, then that client won't have that IP address in its root list until it is able to successfully resolve and update that list.
Awesome. And I remember when you added this feature, I thought this is very clever and going to be very helpful, although not perfect. But I think it's a lot better than nothing at all. So I think it's going to be really helpful. I have a couple of customers using this and no complaints yet. So it's been good.
Yeah. And then the other thing I kind of wanted to mention in this section is that for organizations that have a set of known IP addresses that they do need to bulk add, classic case for this. Oh, actually, no, sorry, I'm skipping ahead there. Ignore me. We'll come back to that in the next section.
Good deal.